All right, so it's kind of two parts. Horizontal and vertical lines first. It's not really that big of a deal. We actually just finished talking about it, so I'm not going to spend a lot of time with that. But then I probably should have called it something different. We're going to call it parallel and perpendicular. So I'm going to write that down. So parallel and perpendicular lines. Okay? So it's kind of two-parter. All right, so let's talk about horizontal and vertical. You know what? We talked enough about it. When we went over that homework just a few minutes ago, I think we got that thing covered. So I'm not even going to go through that. So let's just go to the parallel and perpendicular lines. All right? So what I'm going to do is I'm going to bring over this little graph paper thing. Put it right there. And what we're going to do is take a look at some lines that are parallel to each other. We're going to take a look at some lines that are perpendicular to each other. Oops, pushed the wrong button. What am I doing? What am I doing? Get rid of that. Get rid of this. Get rid of that. There we go. Let's see. Okay, cool. Let's do this. I'm going to go right to the example. This is example 5 in the book. So example 5. So if you want to look at the book later on, this is what we're going to do. They give you some points. They give you this one line, and they say it's at -3, 4, and it connects with 1, -2. So let's graph that. All right, let's put it in a different color so it stands out against this. -3, 4. So let's plot -3, 4. 1, 2, 3. 1, 2, 3, 4. Just put it down. Thank you. Right there. And then 1, -2. Let's plot that. So we go over 1, we go down 2. And then I'm going to connect those right there. And then grab this one. Just make that go down a little bit further. All right, so there's that one line right there. That's -3, 4, 1, -2. I'm going to put another line right there. Actually, I'm going to put what I'm going to do is this. I'm going to copy this, Control-C, Control-V. So I copied and pasted. And what I want to do is I'm going to take this line. Now I copied it, so it's the exact same line, right, as the first one. It has the same slant, everything, the length, and all that kind of stuff. But I want it to go through the point -2, 5. So let's make this a different color. So I want it to go through -2, 5. Let's put a point there. 1, 2, 1, 2, 3, 4, 5. All right, I'm going to take this line and I'm going to put it right through -2, 5. Okay? Here's the question. The question is, if you go over 3, 1, 2, 3, and you go down until you hit the line itself, you don't know how far you went down. Does it hit like right on one of those grids? It doesn't. So I'm not really sure how far it goes down. I don't know if it goes halfway down. I don't know if it's like 0.1, 0.2. I don't know. So that's what we're going to find. So we are going to find that point 3 and then y. I'm going to call it y. So that's what we're going to find. So let's put the points up here. What would I say this point was? -2, 5. -2, 5. Okay? So this point is -2, 5. We kind of know what this point is. We know we went over 3, but we don't know how far we went down. That's what we're trying to find right here. Anybody paying attention? I got boom, 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 boom. Heads down. How many booms was that? 5. 5 heads down. I don't get it. And you're still not putting your head up. Does that mean you're sleeping? You're just not listening to me? Or what? Get your heads up. Get your heads up. Jay, get your head up.
Get your head up, boy.
Cam, get your head up. I'm not going to put up with this mess. I know they're napping. It's ridiculous. I want all eyes up here. Let's act like this is a real class. Let's just act like it. Pretend. Just never. Anyway, so let's do this. What we're going to do is we're going to see something about this these two lines right here. And I'll tell you right now, these two lines are parallel. I'm sorry, I meant to say that later. I copied and pasted these two. So what do you think is true about both of these slopes?
They're parallel.
Well, about the slopes. They're equal to each other. They have the same slope because they're slanted the same direction. Because really, it was the same line. I just picked it up and I moved it over a little bit. That's all I did. So I didn't change the slant of it at all. I didn't change the slant of it at all. All I did was pick it up and move it over. All right, so it has the same exact slope. And if you look at these are parallel. So anytime you have lines that are parallel, anytime you have lines that are parallel, they have equal slopes. Right, that's by parallel, they don't touch, but they have the same slope. That's what we're concerned about. They have the same exact slope. So what I'm going to do is that pink line right there, I need to find that y, so I need to find the slope of the pink line. I'll show you why in a second. So how could I find the slope of that pink line if I don't even know where that point is right there? What am I going to do, Alex? Find the slope of the yellow line. That's right, because they have the same slope. Once I find the slope of the yellow line, then I know the slope of the pink line, and that's going to help me solve for y. We'll show you in a minute why it helps you solve for y. So first of all, let's find the slope of the pink line, which is this one right here. So let's change it back to white. Let's find the slope of that line. This is the yellow line. So we've done this already. We had a whole homework last night on it, so let's do it. So it's 4 minus negative 2. So it's 4 minus negative 2. That's the y. Subtract the x's in the same order. It's negative 3 minus 1. That's 6 over negative 4. And what is that? That's negative 3 over 2. So the slope of the yellow line is negative 3 over 2. So what's the slope of the pink line then? It's negative 3 over 2 because they're parallel to each other, all right? So I find the slope of this one, I find the slope of that one. How is finding the slope of that pink line going to help me find y? Well, I got 3 out of 4 points, don't I? And so I could set it up to find the slope, and I actually know the slope, don't I? All right? So I know the slope because I know the slope of the yellow one. So watch what we're going to do. The slope is negative 3 over 2, and that's going to equal the little formula. So let's put the formula in for the pink line right here. So remember how to do that. It's the change in y or the change in x, right? Subtract the y's, put it on top. Subtract the x's, put it on the bottom. And again, it doesn't matter what order we subtract them in. Would you rather go 5 minus y or y minus 5? I would go y minus 5. I like the y being in the front, okay, first. So I think that might make it a little easier for us. Really doesn't make much difference, but that's the way I'm going to do it. So I'm going to go y minus 5. So y minus 5. Now, how am I going to do the x's, though? If I went y minus 5, I have to start with what? 3. So it's 3 minus negative 2. So now I have a little formula here. Little equation, I should say. It's not really a formula. Little equation. And now, what do I want to solve for? What's the only thing I can solve for? It's y. So I want to solve for y. So how in the world do I do that? Well, first thing I can do is simplify the bottom of this. So this still stays negative 3 over 2. The bottom of it's going to be a what? 5. And then the top, there's nothing I can do with that. I just keep it like that. So now I have to do a little bit of algebra and solve for y. What am I going to get rid of first? Am I going to get rid of the minus 5 on top or the 5 on the bottom that's being divided? Which one am I going to get rid of first? All right, since nobody's answering me, I'll just tell you. It's 5. We're going to get rid of the 5 on the bottom. So I do that by multiplying. I'm just going to teach this as if I was teaching a blank wall because that's kind of what I'm looking at right now. So I multiply this by 5, and I kind of multiply, I multiply this by 5 as well. So that cancels. All right, let's see what this is going to be. Now, unfortunately, this still comes out as a fraction. It's kind of ugly, but that's okay. We can still work with it. It's negative 15 over 2. And then I just put y minus 5. So what I did is I got rid of the 5 on the bottom. Pretty simple, not that big of a deal. Now all I have to do is get y by itself by adding a 5 to both sides. So I add a 5 to this side. But let's think a little bit. This is a fraction. I'm not just going to put plus 5 right there. I'm going to think about fractions. I need a common what? Denominator. All right, so if I make a common denominator of 2, I'm not going to put a 5 here. What am I going to put? What over 2 is 5? 10. So I'm going to put a 10 right there. So I added a 5 here, and basically I added a 5 over here. But I made it 10 over 2. Why did I make it 10 over 2? Because I'm adding it to a fraction with a denominator of 2. That's why I did that. This cancels out, so y equals, let's figure out what this is. What's negative 15 over 2 plus 10 over 2? What's negative 15 plus 10? Negative 5, and it's over 2. And there it is. That's my answer. So y is equal to negative 5 over 2. All right, and you say, okay, well, that's good. That's an answer. What did we really find? If you come back over to this y right here, the amount that we went down was 5 over 2. So what is 5 over 2, by the way? What's 5 over 2? As a improper fraction, or sorry, as a mixed number. It's negative 2.5. That's right. So where's this point right here? I wasn't super accurate with it, but it's pretty close. Where is it? It's 2.5, isn't it? So what is this point? It's 3, 1, 2, 3, and down 2 and a little bit. It's actually halfway. All right, so that point right there is 2.5, or negative 2.5. That's what we just found. All right, by knowing that the lines are parallel, all right, we found the slope of the yellow one. That means that's the slope of the pink one. So we set up a little formula, or an equation. I keep saying formula. Little equation, right? There's the slope. That's what the slope's equal to. We just do some algebra, get y by itself, and it's negative 5 over 2. And that's my answer, just negative 5 over 2. You can leave it, you can write it negative 2.5 if you want to. I don't see any reason why you would want to. It just gives you a chance to make a mistake, because what if you mistakenly wrote negative 1.5? Then that would be wrong, wouldn't it? If you wrote negative 1.5 and circled it, even though you did all this work right, I'm going to mark it wrong, because you are telling me the answer is negative 1.5. Everybody hear me on that? All right, so make sure that if you're going to change it into a mixed number, make sure you do it correctly. I would stay safe and just keep it a mixed number. Now, you must always simplify. Remember we had that one we did on the board where you had like negative 3/9? That simplifies. What does that simplify to be? Right, negative 1 over 3, okay? So you should always simplify it, but if you can't simplify it anymore, just leave it like that. Unfortunately, I think elementary teachers, middle school teachers say that this is simplified. It's not really simplified. You're just changing the form of it. You're just changing it from an improper to a mixed number. You're not really simplifying it. Let's just keep it like this for what we're concerned with, and then we'll be good. All right? Let's do another thing. So we talked about lines that are parallel to each other. What do we say about their slopes if they're parallel? Slopes are what? It's right in front of you. Slopes are what? They're equal to each other. See the equal sign right there? Okay, if they're parallel, they have equal slopes. Then the slopes are equal to each other. What about perpendicular? Let me grab this, because we're going to use it again. What about if the lines are perpendicular to each other? First of all, what does it mean to be perpendicular? What do two lines form if they're perpendicular? So these two lines are perpendicular, okay? What's in common? An X? Any two lines that intersect each other kind of would look like an X. But what specifically? If I said that these two lines are perpendicular, what could you say? That's right. It's 90 degrees. All right? So see, he woke up out of dead sleep to answer that question. All right? So where they intersect right here is 90 degrees. That's what perpendicular means. You've been taught that before, haven't you? Yeah, you should have. All right? Now you have. All right? That's perpendicular. So you know what perpendicular means. Now, what's true about the slopes if they're perpendicular? All right, well, that's a different story. I'll just tell you right now instead of going through this long thing about it. The slopes, they're not equal to each other. They are this. This is the way I've always said it, and I looked in the book. They say it the exact same way. They're negative reciprocals of each other. What in the world does that mean? Well, I'll show you. So what if you had a slope that was 3/4? Okay? So you have some line, you count the rise and the run, and the slope is 3 over 4. What would the slope of a perpendicular line to that line be? Negative reciprocal. So what would it be? Negative, say it, 4/3. Exactly right. Okay? So what you do is you change the sign, and then you flip the fraction. That's a negative reciprocal. Okay? What if the slope was negative 2/7? I'm going to put an arrow. Now, these aren't equal to each other, obviously. They're not equal to each other, okay? I just put an arrow just to represent perpendicular, okay? So what's the slope that's perpendicular to this slope right here? Positive 7 over 2, okay? Megan's paying attention, all right? So it's positive 7 over 2. Those are negative reciprocals. What if I had a slope of 4? What's the negative reciprocal? Again, they're not equal, okay? That's why I put an arrow and not an equal sign. What's the negative reciprocal of 4? Go ahead. 1/4? Negative 1/4, right. Negative 1/4. I'll do one more. Whoops. I'll do one more, like 17. Negative 17. What's the, if the slope of a line was negative 17, what's the slope of a perpendicular line to that? 1 over 17, positive 1 over 17. That's how you do it. It's really simple. You with me? Okay. So here's, let's just erase all this stuff. So here's the example, and we'll end with this. So they give you two lines. The first line goes through, let's do these in different colors again. First line goes through the origin, which is 0, 0, and the other one goes through 3, negative 4. 1, 2, 3, 1, 2, 3, 4. All right, so you got a line that connects like this. All right, now you got another line. And let's go to the pink again. I like that color. So 9, 4. Oops, we don't have 9 on here, but that's close enough. So 9 would be here, and then 4 would be 1, 2, 3, 4. So that would be about right there, I'm guessing. And it also hits this as well. It's got that point right there, 3, negative 4. So the question is, are these two lines perpendicular to each other? How do I find if they're perpendicular to each other? Find the slopes. That's right. So let's do it. Let's find the slopes. Now, you may be able to look at it and say, nah, it's not quite. That looks a little slanted. Doesn't look completely perpendicular. But we can't just go by what it looks like, because it could be really, really close, right? And we can't really tell. We got to know exactly the deal. So what were our points? 0, 0, and what was this? 3, negative 4. So let's find the slope of the yellow line. Then let's find the slope of the pink line. If they're negative reciprocals of each other, then they're perpendicular. If they're not negative reciprocals of each other, then they're what? Not perpendicular. All right, so let's find the slope. This whole lesson, this section is about slopes. So negative 4 minus 0, 3 minus 0. So what is that? Negative 4/3. So the slope of the pink or the yellow one is negative 4/3. Now let's find the slope of the pink one. It still goes, that actually doesn't go through 0, 0. What was this? 9, 4? Okay. And it also hits this, which is 3, 4, correct? Is that right? Oh, 3, negative 4. I'm sorry. I was like, wait a minute. It's not working out. Okay, so 3, negative 4. All right, so let's find the slope of this one. And let's see. All right, let's see and compare them to this, and we'll see if it's perpendicular or not. So we subtract the y's from each other. So 4 minus negative 4. Subtract the x's from each other. 9 minus 3. This is what? 8 over 6. Reduce it. That's 4 over 3. So the slope of this is negative 4/3. The slope of this is 4/3. Are they perpendicular to each other? Why no? Well, one's negative, one's positive, so we got our negative part correct. What's the only thing? They're not reciprocals of each other. That's right. They're not reciprocals. So are these perpendicular? No. So we write not perpendicular. Do you know that's a symbol for perpendicular? Okay. And that's what they ask you. Now, it's a 50-50 shot, right? You could say, yes, they are, no, they're not. So on a quiz, everybody's listening to me, right, on this, because this is important, right? On a quiz, if I ask you, are they perpendicular or not, if you just say, no, they're not, or yes, they are, and you don't show anything to back it up, you're not going to get it right, okay? I don't care if this was right or not, right? You got to show me the work to show why they're not perpendicular. I showed that that's negative 4/3. I showed that's positive 4/3. They are not negative reciprocals of each other, so I can say not perpendicular. Everybody good? Okay. So here's your homework. We'll call it 2.2b. Come on. So it's section 2.2 part B, and it's page 110. And we are doing 39 to 56. I don't even know if that's what I wrote down in your lessons. Did I write that down or not? I said to 50. I'm changing it to 56. Okay, so 39 to 56. All right, so we're doing 39 to 56. It says 50 on your lesson plan thing, but I made an audible, all right, and I changed it to 56, all right?